For the logistics drone, we have a distance sensor to let us know if the drone is at or below 7 feet, servo motor to lower and retract the winch, DC motor representing the motors for the propellers, a buzzer to give us audible indication of lowering and retracting the winch, LED to give us visual indication of established signal or not. These switches will represent our inputs. First switch will represent a signal or not. Second switch will be a drop-off location or not. And the third switch will be if the package has been received or not. Currently, we do not have any signal. LED is blinking and the motors are off. We will establish signal and the LED will stay lit and the motors will start running. We will then move on to seeing if we're at the drop-off location or not. Currently, we are not. Saying continue to drop-off location. Go ahead and arrive at drop-off location, but our drone is above 7 feet, so the drone needs to descend. We will have the drone descend to 7 feet or below. We will get audible indication knowing that our servo motor is going to lower the winch. And there we are. We will then stay at this position until the package has been received. And once we retrieve the package, we will get audible indication of the servo motor returning back to zero degrees and retracting the winch, and the drone will return back to base. And that will be a completed delivery. So for the coding, we have the library for the servo motor allows us to control the servo motor. We have the pin definitions, which are going to give us our identifications of what pins will be controlling what devices. Pin 2 is for the signal. Pin 3 is for drop-off location. Pin 5 is for package being retrieved or not. Pin 6 is for the output of the servo motor. 7 is the LED. 8 is the motor. 9 is the buzzer. We then also have the trig and echo pin for our distance sensors, which are on pin 10 and 11. We have these Boolean functions that give us true or false, and these are for our buzzers. This variable here gives us our max altitude, which is 84 inches or 7 feet. Servo is declaring our winch servo. Distance here, we are going to clear our trigger pin, allowing us to then send out the pulse from our trigger pin high. We're going to delay for 10 microseconds. Then we are going to turn off the trigger pin. Duration here will give us the measured time for the pulse to get sent out and return back to the echo portion of the distance sensor. Our duration here is going to give us our distance. Duration over 148 gives us our distance. We have no signal here, so LED is just telling us, it's just printing our LED, no signal status. And yeah, this loop here gives us our iterations for LED blinking when we have no signal. Void setup, input switch configuration, pin mode. This gives us whether our pins are going to be inputs or outputs. Signal location and retrievable package are all inputs. The trig pin for our distance sensor is an output. The echo pin for the distance sensor is an input. The servo, LED, motor, and buzzer are all outputs, as we can see here. This, we're initializing our servo at 0 degrees. Here we are establishing our serial monitor, letting us know that the drone has begun and it's doing altitude check. Here we are going to reset our LED pin and our motor back to its initial states at the beginning of each cycle. These Boolean functions are going to let us know if our signal, location, and package retrieved are true or not. Current distance is going to get our read distance and let us know if where our drone is at 7 feet or below. This Boolean function is going to tell us true or false if our drone is at or below 7 feet. That is when the current distance is less than or equal to 84 inches. Here, our functions are going to be starting. If we have signal, we are going to turn the LED pin to high, turning on the LED to a solid light, and turning the motor pin to high, turning on the motors. If the location is found, we are then going to see if we are at 7 feet or below. If we are, we're going to say that our trigger pin is false, meaning we have not sounded the buzzer. We're going to say that the winch is lowering. The buzzer is going to sound off. We're going to delay for a bit, turn off the buzzer, delay for another bit, and send the servo to 90 degrees. Then say that the buzzer has went off and the retraction buzzer has not. Then if the package has not been received, we're going to say that the winch is held in the down position. If the package is received, we're then going to say that the buzzer is false, it has not been sounded. We're going to say that the winch is going to retract. The buzzer is going to go off. We're going to delay for a bit, turn off the buzzer, delay for another bit, and send the servo back to 0, retracting the winch. We're then going to send our reaction trigger to true, meaning it went off. Our package has been received, so we're going to return back to base, delivery complete. Else, we are going to remain at the location until the package is retrieved. Else, no path. If we're not at 7 feet or below, we're going to print out the distance that the drone is at. We are going to have our triggers at false, and we are then going to repeat until we are at 7 feet or below. If we're not at drop-off location, we're going to continue the drop-off location. Our triggers are still false. For the buzzer, if there's no signal established, this is to blink our LED 5 times until we establish signal. We are going to we're going to reset our servo to 0 degrees and our triggers to false upon completion of our whole loop. And we're going to pause for a bit until the next iteration of the cycle.